Now we're doing the AP Statistics Unit 3 review. This is over sampling and experimental design, which is another important unit in life, in school, and in statistics, of course. There are 3 types of sampling design. Now, we're in Unit 3. These are the types of sampling design, which we have 5 of, not 3. The first is a simple random sample. This is commonly abbreviated SRS, which is a little confusing because 3 of the 5 have the same initials. But anytime you see SRS, that is referring to a simple random sample rather than stratified or systematic. This is where you have a list. You have all names on a list. That list is called the sampling frame. And then you randomly select a set number of names. So every individual has an equal chance of being chosen, and every group of n individuals also has an equal chance of being chosen. So we're not limiting it in any way on how many people can come from each group. So I can't set it up so that I can only get 25 juniors, 25 sophomores, and 25 seniors. It's just in general, so it's possible for all 75 to be seniors in that case. Not probable, but possible. For a stratified random sample, this is where you sort the population into groups based on a common characteristic, and then you randomly choose some people from every group. So this would be where I limited it and say 25 sophomores, 25 juniors, 25 seniors. Sometimes we do unequal numbers when certain percentages of the population are much larger than others. So we could either do all equal or we could ratio it out depending on how many people we have in each group. The third type is a cluster random sample. This is where you randomly select a location or multiple locations and survey everyone in those locations or single location. The advantage of clusters is a lot easier. You only have to go to a couple of locations instead of going to every single location. You also don't need a sampling frame. So cluster is a lot easier, but it also has more variability because sometimes clusters are similar to each other. So the best way to counteract that is to go to multiple places, not just one place. The more places you go to, the less variability you'll get. Systematic random sample is where you select sample by picking every nth people and you choose a random starting point. So I could survey the 4th person. I could survey every 4th person. I have to choose my random starting point between 1 and 4. That's where randomization comes in. Or every 10th person, however many people. The next thing is the multi-stage sample. This is any combination of any of these techniques. This is not used often in AP Statistics, but this is used quite often in the real world. Because in the real world, typically it's hard to do any one of these. When you have a really large population, it's hard to do any one of these. Instead, you do a combination of these. For example, if you wanted to survey people in the US, you might take a cluster sample first. So cluster everyone based on what city they live in. Then you might randomly select 100 people in the city. 100 cities. You're not going to survey everybody in those cities, though. You might survey 100 people from every city. So it just does successfully smaller stages. So I might combine systematic, cluster, stratified, simple, just multiple steps, any of these combinations. On the AP test, they really like to make sure you know the difference between stratified and cluster. So these two, they want to make sure you know advantages and disadvantages of them. Cluster is easier, stratified is more accurate. Remember, none of these methods are biased, but stratified has the least variability. So when we can do stratified, we typically want to, because it gives us a more precise answer. You know for sure it's representative of the different populations. They'll also throw in simple sometimes. They want to make sure that you know why stratified is better, but also why sometimes another method might be better. So make sure you know the differences between these and advantages, disadvantages, how to describe all of that. This whole thing is basically vocabulary. Vocabulary was the main focus in this unit, and then applying those vocabulary terms. This next slide is types of bias. The first type of bias is convenience sampling. This is where you ask people who are easy to ask. So for example, if I want a survey of Allen High School students, I could just send out a survey to the 150 students in my AP statistics classes. More like 130 people in my AP statistics classes. And then if I try to use that for the whole population, I'm leaving a lot of people out. So it was convenient for me, but that was not representative. It was not random. It's not okay. Under coverage bias is where some groups are accidentally or purposely left out of the selection process. For example, selecting names from the phone book missed people with unlisted numbers, people without phones, and people with only cell phones. So I'm leaving out a lot of groups of people. A lot of the other biases cause undercoverage bias. For example, convenience sampling. It was easy for me to ask the people in my class, but that's not representative because those are going to be more seniors than sophomores and juniors, also people taking AP courses and all of that. I would not have a representative sample of the whole school. Voluntary response bias is where people select themselves to participate in the study. Usually only people with very strong opinions respond. For example, if you put a survey online and then like on your Twitter page and you have people respond to it, only people who really care are probably going to take the time to do it. That's also a convenient sample because it was an easy method for you, but it wasn't representative. And then both of these are bad because it leaves people out, causing undercoverage. Non-response bias is where you do randomly choose people, but then people don't respond. Non-response and voluntary sound kind of similar. They have kind of the same effect. But voluntary is where people volunteer. You never did a random selection. Non-response is where you did a random selection, but then some people did not respond to your survey. So those never happen at the same time. These cannot happen together. Both of them can happen with any of the others, but they do not happen together. Non-response bias is bad because it causes undercoverage. People who don't have time to respond or who don't care enough to respond, even though they were randomly chosen, can be similar to each other. You can be leaving out groups of people. Response bias is where something about the surveyor or the surveyed person or the wording of the question causes you to get wrong answers. For example, if a cop asks kids if they do drugs, you're not going to tell a police officer that you've done something illegal. So whether it's true or not, you're going to be answering no. That's response bias. Okay, some experimental design vocab. First is experimental unit. This is the single individual, person, animal, plant, etc., to which the different treatments are assigned. A factor or an explanatory variable is what we're testing. So it's, or what we're changing, what we're using to see if we can get a response from. Typically, we think of this with an experiment, but it's also used a lot with a study. So don't be concerned if you see that. But in a study, you're just observing versus in an experiment, you are applying the factor or the explanatory variable. A level is a specific value or type for the factor. A response variable is what you measure at the end of the experiment or study. A treatment is a specific experimental condition applied to the units. So this can be a combination of different factors. It's the same thing as the levels if you only have one factor though. A control group is used to compare the factor against. This can be the placebo or the current item that you're already using. You do not have to have a control group in every experiment as long as you have at least 2 treatments. But you cannot have an experiment with only 1 treatment and nothing to compare it against. A placebo is a dummy treatment that has no physical effect. Blinding is where you don't know what treatment you got or the evaluators don't know what treatment you got. One way to do this is by giving some people a placebo. So a placebo is a method of blinding. A double-blind experiment is where the units and the evaluator do not know which treatment the subjects received, which is not always possible. Sometimes it's impossible to hide. Sometimes you can't let people, or sometimes it's impossible to hide, sometimes it just doesn't matter. Like with the rabbits, we talked about the rabbit food example back in the first semester. You don't need to hide from the rabbits what type of food they're getting. If they see the hippity hop logo, they're not going to start hippity hopping. They're just going to continue on with their life. They can't read, probably. There are 3 types of experimental design. The first is completely randomized design. This is where all experimental units are assigned randomly to the different treatments. Just you take all of them and you randomly assign some to treatment A, some to treatment B, however many treatments there are. Randomized block is where you sort them into groups first, and then you randomly assign the different treatments within each group. So it's very similar to stratified. They're sorted first, but randomized block is when it's an experiment. Stratified is when it's an observational study that you're doing. Or a survey is also for stratified. So you sort them into groups first based on similar characteristics, and then within each group you randomly assign to the different treatments. So we did the dog example here. For randomized block, we sorted them based on the breed, and then within each breed, we assigned some of each treatment. For your blocking variable or your stratifying variable, you always want to pick something that you think is going to affect the response. When we did the sample in class with the dogs, the breed really affected the bone density, the clinic not so much. You always want to pick a variable that will affect the response. That's how we reduce variability, which is the entire purpose of randomized block design. Matched pairs is a type of randomized block design. There are 2 methods of matched pair experiments. The first is where you pair up units based on common characteristics and randomly assign 1 to each of the 2 treatments. So I could pair the 2 most similar people in my class together, maybe the 2 top grades, and then the next 2 and the next 2 and so on. Or identical twins or married couples. Anything like that could be a natural pairing as well. And then one gets one treatment, one gets the other, so you know your 2 treatment groups are similar because you specifically put 1 of each type of person in the group. The other way is to have all experimental units do both treatments in a random order. For example, a taste test. You try both items, you don't know which is which, that's called blinding. It's a random order, and then you decide which type of spaghetti sauce you like better, and you're super surprised when you've been eating the wrong spaghetti sauce for your entire life. There are 3 principles of experimental design. The first are controls. You want to keep everything as similar as possible for all experimental units other than their treatments. If possible, they don't even know what their treatments are. Everything is the same. So with the rabbits, they got the same amount of food. They got the same amount of water. They had the same amount of exercise, vitamins, anything else that rabbits do with their free time. I don't know what rabbits do. You keep everything the same. The only thing you change is the type of food they get. You do that as much as possible. Those are called controls. This is not the same thing as a control group. The next step is randomization. This is the use of chance to assign subjects to treatments. You can't pick which rabbits go to which food. Or like the example in the PowerPoint before was you caught the rabbits, but bigger rabbits were easier to catch. So that's why our rabbits ended up bigger, because they started off bigger. So make sure you randomly assign treatments to the subjects. You cannot choose. You could also be biased. And I could intentionally pick the big rabbits to prove that my rabbit food is better. The third principle of experimental design is replication. You have to do an experiment on many experimental units to quantify natural variation in the experiment. So I can't just use 2 rabbits, one with hippity hop, one with the lame other food. I have to have several rabbits in the group because my rabbit might have just been better to start off with. So I have to make sure I have multiple rabbits when I do that, or multiple whatever the experimental units are. I'm just using that example because we did that in class. The differences between a study and an experiment. So this is really important. I've seen this multiple times. You're going to see it on the FRQ practice today. In an experiment, the person or unit, whatever they might be, are assigned a treatment. In a study, the person chooses their own treatment. So it's the choice. Were you randomly assigned the treatment, or did you pick your treatment? If you picked your treatment, it's a study. If you didn't pick your treatment, it's an experiment. If it was randomly assigned to you, it's an experiment. Remember, there have to be multiple treatments in order for treatments to be randomly assigned. Make sure when you explain that you include context. What should have been randomly assigned? So with the rabbits, the rabbit food had to be randomly assigned. Make sure you specify that. You don't just say treatment. That's putting the context. Remember, context is super important on the AP test. You need to explain things in context, not just in general. Remember, since studies have confounding variables, they cannot prove cause and effect. However, experiments can, since we control the confounding variables. So with the study, because you got to choose your own treatment in quotation marks, that can affect the response variable as well. So there can be a confounding variable if you have anything that can affect the explanatory and the response. Versus in an experiment, nothing affects the explanatory variable because it was randomly assigned. So we can't have a confounding variable. Instead, we just have lurking variables, which we try to control. But because we randomly assign treatments, there is nothing that affects the explanatory except randomization. So there are no confounding variables in an experiment. Thus, we can show cause and effect for similar experimental units under similar conditions. Ideally, we would always do an experiment, but sometimes that is not possible for moral or technical reasons. And make sure you don't pick a sampling design for an experiment or an experimental design for a study, especially stratified and randomized block. They sound so similar, it would be easy to get them confused, but remember, stratified is for a study, randomized block is for an experiment. Remember, if you took a random sample, it's never biased. As long as everybody responded, it's not biased, but they can have high variability. So a cluster sample, for example, is not biased, but it can have high variability, which we want to reduce a variability within a study or an experiment. When describing an experiment or sample, you are giving it like how to take a sample or how to assign treatments. You are giving instructions. So you are telling someone very specifically what they're supposed to do. They should be clear, detailed, and specific. Assume the person reading them is an idiot and or very difficult, and they will only do something if you specifically tell them to. So you need very, very clear steps. Remember, if needed, you have to number the population. Give a number range if you're using a random number generator. So you can't just say number the population 1 through 2,000 and then pick numbers with the generator. You have to say between 1 and 2,000 with the generator. You select without replacement when using a hat, or ignore repeating numbers / select unique numbers if using a random number generator. It's the end of the PowerPoint. Remember, as always, email or go to office hours if you have any questions. Hopefully this helped recap and you feel more confident in your Unit 3 skills now.